Dear students, welcome to this module on the role of proteins and fats in exercise. Now, as an introduction, we all know about the macronutrients, carbohydrates, proteins and fats. The three macronutrients, carbohydrate, protein and fat, all perform equally important roles in our human body. The macronutrients are the main components of our diet. Protein should consist of about 10 to 35% in all our diets. Amino acids, which are broken down from proteins, are the building blocks into our body. They are all linked together in complex formations. The misconception about fat is also that it is bad for us. In fact, fat is very much essential for maintaining a healthy body. The diet should also consist of about 20% of total requirements from fat. Fat has many main functions, and main is the protection to our body. This includes insulation to keep our body temperature right and also helps in cushioning to protect the body organs. It also promotes the overall growth and development as well as maintain the cell membranes. Fat in addition plays a vital role in digestion of vitamins, especially the fat soluble vitamins, vitamin A, D, E and K. They need fat in order to be absorbed and used in the body. As an overall view of this module, let us see the objectives now. After going through this module, you will be able to explain the protein and fat use during exercise and also learn the factors affecting the use of protein during exercise in our body. Now, let us look into all these aspects in detail. Protein is used during physical activity and also between times during exercise. Physically active people use protein just as other people to do the build up of muscles and other lean tissue structures, and also to some extent to extend the fuel activity. The body does, however, handle protein differently during activity and also during rest. High biological value such as milk, egg, lean meat is highly recommended. If a fat high in diet is ill advised for active people, what about a high protein diet? Athletes may have slightly higher needs for proteins than others do. But given the margin of safety used in establishing the recommended dietary allowances, no added allowance is made for work or physical training. The protein needs of most people, including the athletes, are covered by a balanced diet of the ordinary foods. And also, protein is used for muscle building process, which is essential for a sports person. The synthesis of body proteins is suppressed during activity and for several hours afterwards too. In hours following this period, protein synthesis accommodates beyond normal resting levels. And remember that the body adapts and builds these molecules, cells and tissues it needs for the next period of activity. Whenever the body remodels a part of itself, it also tears down old structures to make way for new cells and tissues. Repeated activity, protein dismantling and protein synthesizing equipment of each muscle cell to make needed changes is to adapt. The physical work of each muscle cell acts as a signal to its DNA and as well the RNA to begin producing the kinds of proteins that will be best support to do the work. Take for example like jogging. In first difficult sessions, the body is not yet equipped to perform aerobic work. Each session, the cell's genetic materials gets the message that an overhaul is needed. In the hours that follow the session, the genes send molecular messages to the protein building equipment in the body and what new structures to build and to within limits of the genetic potential it responds to. Among the new structures are more the mitochondria, the powerhouse of the cells to facilitate the different efficient aerobic metabolic process. Over a few weeks' time, the remodeling occurs in the body and jogging becomes easier, which was a difficult session earlier. Such remodeling requires protein, and this is the work done by the protein in the body and especially the high biological value proteins. During active muscle building phases of training, an athlete must add between 1/4 ounce or 1 ounce between 7 and 28 grams of body proteins to existing muscles mass each day. This increase occurs only during periods of building, not at times of maintenance when athlete exercises at higher intensities. And also, in addition to these roles, protein is also used as fuel during exercise. Not only do athletes retain more protein in their muscles, they also use protein as fuel. Muscle speeds up their use of amino acids for energy during physical activity. Just as they speed up their use for fat and carbohydrates, we see that 10% of total fat is used for fuel source, both during active people for all days, and also the endurance athletes use up a large enormous amounts of all energy fuels, but such athletes also eat more food and therefore usually consume enough proteins of good nature. And also, acting as the fuel, it also says that diet affects protein use during activity. In addition, protein activity is also another function. The factors that affect how much protein is used during activity seem to be there that influence in one's diet. People who consume diets adequate in energy and rich in carbohydrates usually use less protein than those who eat protein and fat rich diets. Recalling that carbohydrates spare protein for energy from being broken down to make glucose whenever needed. Since physical activity requires glucose, a diet lacking in carbohydrate necessitates the conversion of amino acids into glucose. So does a diet high in fat, because fatty acids can never provide glucose. The intensity and duration of activity affect the protein use during the activity and especially during exercise. A second factor, the intensity and duration of the activity, also modifies the protein usage inside the body. Endurance levels in the athletes who train for over an hour a day engaging in aerobic activities with moderate intensity and long duration may deplete their glycogen stores by the end of their workouts and become somewhat more dependent on the body protein for energy. The protein needs of bodybuilders and weightlifters are slightly higher than those of sedentary people, but not as high as some recommendations and certainly not as high as the protein intake many bodybuilders consume. And in addition to these, protein also has usage during the training process. A third factor that influences a person's usage of protein during physical activity in the body is extent of training that the person undergoes. Periodically, the higher degree of training, the less protein a person uses during the activity. Protein recommendations for active people are the same. As mentioned earlier, all active people and especially those who work like athletes probably need a little more protein than the sedentary people. Endurance athletes use more protein for fuel than power athletes who use to retain the proteins in the body, especially in the muscles, and use it for the sport when it happens. The power athletes use less protein but still use some and retain much more. Therefore, all athletes in training should attend to protein needs but should back up the proteins with ample carbohydrates, otherwise they will burn off as fuel and very little protein will be retained in the muscle for usage during exercise. And now we will see the recommended protein intake for athletes. The recommended protein intake for the athletes is 1 to 1.5 grams of proteins per kilogram of body weight each day, and especially the foods from the high biological value, somewhat higher than the amount recommended for the general population, which we tell is 1 gram of protein per kg of body weight. Another authority suggests different protein intake for athletes pursuing different activities, and athletes who want to build muscle mass should first meet their energy needs with adequate carbohydrates and then check with the protein levels that they need as well. And apart from all these functions, we will have to see what is the function of fat during this physical activity and exercise. An active person who eats a fat-rich diet with little carbohydrates will sacrifice the athletic performance and will needlessly degrade the protein tissues as the body struggles to obtain the glucose it needs from amino acids. Furthermore, a high-fat diet is a major risk factor for cardiovascular diseases, since even physically active people can suffer heart attacks and strokes. Every reliable source speaks out against high-fat diets for active people. In contrast to dietary fat, body fat stores are of tremendous importance during this physical activity, as long as activity is not too intensive. Unlike glycogen stores, fat stores can fuel hours of activity without running out. And now we will see the factors affecting fat use during exercise. As protein is used during the stores, the fat is also used in physical activity liberally from the fatty acids, the internal fat stores, and also from the fat under the skin. Areas that generate greatest amount of fatty acids to the blood, although they may not appear fatty, are spot reducing and do not. This is why spot reducing does not work. Muscles do not own the fat that surrounds them. Fat cells release fatty acids into the blood, not into the underlying muscles. Then the blood gives to each muscle the amount of fat that it needs automatically. Proof of this fold measures the same in both arms, even though the muscles of one arm works much harder and may be larger than those of the other. A balanced fitness program that includes strength training, however, will tighten muscles underneath the fat, improving the overall appearance, keeping in mind that some body fat is essential to good health. Now we will see how this fat is influencing the duration of activity during exercise. Early in an activity, as the muscle draws on fatty acids, blood levels fall down. If the activity continues for more than few minutes, what happens automatically is that the hormone epinephrine is released, and in response to this release of epinephrine, fat cells begin rapidly breaking down through their stored triglycerides and liberate fatty acids into the blood. After about 20 minutes of physical activity, the blood fatty acid concentration surpasses the normal resting concentration. Thereafter, if we look, the sustained moderate activity usually uses body fat stores as a major fuel source in addition to carbohydrate and proteins. And now, as we see the intensity of activity and its role with fats, the intensity of the physical activity also affects the fat usage in the body. In general, as the intensity increases, fat intake is less and less of contribution to the mix of fuels used. Remember that fat can be broken down for energy is only one way, by aerobic metabolism, and in fact the use of fatty acids for energy requires more oxygen even on per kilocalorie basis than does the use of glucose. This is because fatty acid oxidation generates so many components such as acetyl-CoA molecules that enter the TCA cycle, and because each turn of the cycle generates so many hydrogens that travel through the electron transport chain to generate and liberate oxygen, which is required during the exercise for an athlete. And abundantly, the fat activity oxygen must be available in larger capacities. And if a person is breathing easily during activity, the muscles are getting all the oxygen they need and are able to use more fat in the fuel mixture. And now, during the training period, if we see, the aerobic activity produces adaptations that permit the body to draw heavily on fat for fuel. Training stimulates the muscle cells to manufacture more and larger mitochondria, the powerhouse of the cells, the cellular structures that conduct the aerobic metabolism. Another adaptation is that the heart and lungs become stronger and better able to deliver oxygen to muscles at higher activity intensities. Still, another hormone in the body of a trained person slow the glucose release from the liver and speed up the fat use instead. These adaptations automatically take place inside the body and reward not only the trained athletes but all the active people. A person who exercises aerobically every day becomes well suited to perform the different tasks ease and without any difficulties. Now, if we look into the recommended intensities and durations and its relation to fat, the healthcare professionals frequently advise the people, especially the athletes and sport persons who want to control their body weight and lose fat, to engage in activities of low to moderate intensity for a longer duration, such as an hour-long fast-paced walk. The reason behind such advice is that people exercising at low to moderate intensity are likely to stick with their exercise programs for longer times and are less likely to injure themselves as they are used to such activities. The intensity and type of physical activities that are best for one person may not be good for another person, as the body intensities are different. The intensity to choose depends on your present fitness and work so as to breathe fast but not so fast as to incur the oxygen debt. A rule of thumb is that you should be breathing easily enough to talk but not sing. If you can sing, pick up the pace. If you have to huff and puff to talk, slow down. If you have been sedentary for the past few years, the activity intensity that will initially make you breathe slightly fast will differ dramatically from the intensity at which a fit person will breathe slightly faster. And now let us see to choose a diet to support this fitness with combination of all these macronutrients. First, remember that water is depleted more rapidly than any other macro or a micronutrient. A diet to support fitness must provide water, energy and all other nutrients. If we look into the water requirements, even a casual exerciser must attend conscientiously to their fluid needs. Physical activity blunts the thirst mechanism. Especially in cold weathers, we will see that during activity thirst signals come too late. So don't wait to feel thirsty before drinking. To find out how much water is needed to replenish exercise losses, weigh yourself before and after activity. The difference is almost only water. And with this we can match to find what is the water requirement to our body. The nutrient density, a healthful diet, is based on nutrient dense foods. Foods that provide an adequate supply of vitamins and minerals in addition to protein and fat for energy they provide. Active people need to eat both for nutrient adequacy and also to meet the energy requirements. They are not immune to heart disease and cancer, and so much limits fats. A diet that is high in carbohydrates, 60% of total calories or more, low in fat, 25% or lesser, and an adequate protein that is 12 to 15% of the total contribution ensures to fill the glycogen and other nutrient stores that are required during the exercise. And when we look into the carbohydrate requirements, on 2 occasions, the active person's regular high carbohydrate, fiber-rich diet may require a temporary adjustment. Both of these exceptions involve training for competition rather than fitness. During intensive training, energy needs are higher, so high that they may outstrip the person's capacity to eat enough food to meet them. At that point, added sugar and fat may also be needed. The person can add concentrated carbohydrate foods such as dried fruits, sweet potatoes, nectars, and even high fat foods such as avocados, nuts, cookies, and ice cream, and still a nutrient rich diet remains central for adequacy's sake. While vital is the energy is to support the performance during the exercise. The other special occasions is the pre-game meal before an event, when a fiber-rich diet or bulky foods are best to be avoided. The pre-game meal is discussed in the later session. And now the protein requirements. In addition to the carbohydrate and fats, the protein is also essential for the physically active people. How much of what kinds of foods supply enough protein to meet the needs of the person during exercise is very important. Foods like meat, milk products are rich in proteins, are proteins with high biological values, but recommended that active people emphasize these foods. We narrow advice for many reasons. For one thing, all people must protect themselves from heart diseases, and even lean meats and low fat milk products containing fat, much of it saturated fat. For another reason, as emphasized repeatedly, active people need diets high in carbohydrates, and of course meats have none to offer. Legumes, grains and vegetables provide proteins with abundant carbohydrates and very little fat, and will be best suitable during the exercise. For example, a performance diet is likely that a person weighing 70 kilograms, for example, and who is engaged in a vigorous physical activity on daily basis could require more than this need. The person could choose a variety of nutrient dense foods to meet his body requirements. The meal supplies over 130 grams of protein, which is double the body weight, more than the highest recommended intake for such person. Obviously, the more energy a person requires, it has to be compensated from the protein source, and summing up, the foods chosen are nutrient dense. The relationship between energy and protein intake thus breaks down only when people meet their energy needs with high fat, high sugar confectionaries. Athletes who train exhaustively for endurance events may want to aim for somewhat higher carbohydrate intakes. Beyond these specific concerns of total energy, protein and carbohydrate, the diet must be beneficial to the athletic performance, is remarkably similar to the diet recommended for most people. Now, when we look into the meals before and after competition, no single food improves speed, strength or skill in competitive events. Although some kinds of foods do support performance better than others, as already explained, still a competitor may eat a particular food before or after an event. The pre-game meals indicates that the pre-game meal or snacks should include plenty of fluids and light and easy to digest foods, and it should provide between 200 to 300 kilocalories primarily from carbohydrate rich food sources, and these are essential for an athlete. The meal should end 3 to 5 hours before competition to allow plenty of time for the stomach to be empty before the excursion in the event. Breads, potatoes, pastas, fruit juice, which are carbohydrate rich choices, at the same time low in fat and protein, such as vegetables, high bran cereals, usually before competition, is highly recommended. Fiber in the digestive tract attracts water out of the blood and can cause stomach discomfort during performance. Liquid meals are easy to digest, and many such meals are commercially available in the markets nowadays. Alternatively, athletes can mix the non-fat milk or juice, frozen fruits and flavorings in a blender along with the seasonal fruits so that it will be energetic. Similarly, the post-game meal after the event shows that eating a high carbohydrate food after physical activity enhances the glycogen storage. Since people are usually not hungry immediately following the physical activity, carbohydrate containing beverages such as the sport drinks discussed earlier may be preferred. If an active person does feel hunger after an event, the protein, fat and fiber are the ones Foods high in protein and fat should be avoided during the first few hours after activity, as these foods may suppress hunger and thus limit its carbohydrate intake. As a conclusion to this module on role of proteins and fats in exercise, foods, as we all know, provides an awesome blend of nutrients: proteins, carbohydrates, fats, fiber, minerals, vitamins, antioxidants and phytonutrients that build muscle, supply energy, decrease inflammation and also boost the recovery process. Of course, one can eat solid foods or drink smoothies, and the amount of each macronutrient can vary depending on the needs as well as the personal preferences and tolerance. In terms of timing, an athlete has about 1 to 2 hours on both sides before and after an event and training to get the maximum benefit. And according to the most recent data, the total amount of protein and carbohydrate consumed over the course of the day is far more important to lean mass gain, fat loss and performance improvements during the event than any other performance activities and also the time strategies. So enjoy the workout and the healthy sumptuous meals too during the events. Thank you.